One of the tricks that I'm using here is the card itself is composed of a rectangle with, let me restart this so you can see a little better, a rectangle with rounded corners. It's got a white background or fill color and a blue stroke. In addition to the rectangle, we're going to have some image, some random image that is selected in game.lua. So if I want to do some kind of composite stretching or scaling or movement effect, I've got two choices. Either I can modify each of those individual units, that is, I can modify the rectangle and the image, or I can be smart about it and I can create a display group and then insert both of those objects and modify the display group. And so what I'm saying here is I've created a display group. Inside my code, I call it card. Then I insert that card into the group that was passed to the create function. So now that it'll be managed by that group. Then I position the group where I'm told to put it. And this is positioning by the center of the group, the 0, 0 vertex of the group. And then the trick is I'll create my background. So that's this rectangle right here, this rounded rectangle. And I will put it at 0, 0 within the group. So while the rectangle is at position 0, 0, if I move the group, I move the rectangle. So this rectangle here is probably at like, I don't know, 60, 70. And this one is probably at about 160, 70, and so on and so forth. So I'm moving the group, and the contents of the group move with it. So our background is a rounded rectangle, stored in the card, placed at 0, given a width and height as specified in the create parameters. I give it a corner radius of 8. I could have changed that to any arbitrary value, but 8 seemed to be a nice value to give it a good rounded corner. I set the stroke color to blue and make it kind of thick with a stroke width of 2. Then I create the image that I've been told to create, so image number whatever out of folder whatever, or the images folder. And one little trick that I use here is because I allow the algorithm to, in a sense, say, hey, I want this card to be taller than it is wide, or wider than it is tall, I would like an easy way to make sure that my images are always within the boundaries of this rectangle. So the first thing I did was all of my source images, if you look at them, I've made sure that they are in a square shape, so equal width and height. Now the shape itself within the square can be arbitrarily shaped, but the texture itself must be equal width, equal height. And the reason is I'm using a little trick here where I say if the card is wider than it is tall, then we'll choose that as the size of our image. So width is, I'm sorry, if the width is greater than the height, we'll choose the height, which is the smaller one. Otherwise, we'll choose the width. So the point here is, whatever size I make the texture, I want to make sure that it fits within both the width and the height of my card. So I choose the smaller of those and make sure that I make the image that size. And then, for people who want to adjust this game later, I added an additional line of code, which you could just simply comment out, where I allow you to apply a scaling factor to the size simply by multiplying it by a value. So in this case, I've commented it out, but I multiplied it by 0.8, and that's basically saying choose the smallest dimension and then make it 80% of that. And then, it's a little bit hard to read the code because it takes up so much space here. I use display new image rect. I place the image inside of the card group, which we created above. I pull the image from image folder slash, and then I use dot dot, which means append or concatenate, and images, the name of the folder, and I concatenate a forward slash, then the number of the image. Oh, I forgot to show you that. Within these folders, the images are named 1, 2, 3, 4, 5, 6, etc. And there are more in some folders. For example, Mix has 20 images, so there's 1 through 20. So images, the folder, images, the string that was passed in at the top here, which could be Corona Crush, Lost Garden, Niku Fruit, etc. Slash the number of the card, and then PNG. And then finally, the width and the height, which I have decided to make the same because I want it to be a square.
Let me ask you if you
So if I were
if they're the same, if they're a square, why are we doing the calculation?
Okay, because the image is a square, but the card shape may not be a square. So let me show you. This is the square case, but in game.lua, when I call this, I could say make the width of the card 50 and make the height of the card 60. So we haven't looked at this code yet, but in game.lua at the very top, I have some code that specifies the width and the height of the card. Now remember, the card is a composite object. It's a rectangle and a shape. The rectangle's job is to act as the card background and the image that you see when the card is quote-unquote flipped over or hidden. And the image itself is the part of the card that we care about, which is the thing that we're trying to match. So now when I reload this, these cards are going to be taller than they are wide, and the code will choose to make this image a square, which is not any wider than the width of the card.
Okay.
So I can make this really extreme, like
so
100.
So you've essentially created this so that someone could create a custom version of something, not that it's just hard coded as a square.
Create a custom version of this without having to worry about all the math.
Okay.
So the short version of this is, if you want to add more images, make your images for the actual pictures that go on the card, make them square. The image portion can be any shape you want, but the texture itself must be square. So if it's 100 pixels wide, it has to be 100 pixels tall.
Okay.
Then, once you've done that, the code itself will always properly calculate the actual width the image needs to be to display on the card. You know, if I wanted to get really extreme here, make it 10 pixels wide and 100 pixels tall, well, okay, that's too much. Sorry. That's terrible. There we go. So you can see that the code is continually adjusting this so that the image never overlaps the edge of our quote-unquote card.
Okay.
Let me put this back to the actual values. Okay. So what I was demonstrating here is so far what we've done. We created a group, which we called card. We positioned that group based on the XY position we were told to put it in. Then we put a rectangle, a rounded rectangle, in the group, and on top of that we put a image that uses the folder and the image number that we were told to use. And then normally this would be false, because we want the card to start off hidden, in effect. But I'm going to make it true so you can see where the fruit is. I'll try to make it that way anyways. So as you can see here, we got these fruits, and if you look carefully, we have 2 cherries, 2 apples, 2 oranges, 2 lemons, 2 bananas, and 2 pears.